Hello, I'm Emma-Louise Coffey, and you're welcome to the Dairy Edge, the Teagasc Dairy podcast. We're bringing you the latest information, insights and opinion to improve dairy farm performance. Here at the Moorepark Open Day, we speak to researcher Stephen Butler about reproductive technologies in dairy farming, including an update to the new Irish Sexing Technologies Lab, as well as the results of the IVF trial carried out this spring.
We did establish a sex semen lab, a temporary sex semen lab here in 2013, just for the purposes of a field trial. And at that time, we thought that, because of the demand that was becoming, because of the demand that was growing in the dairy industry, that there would be a lab present by now. So we've, in conjunction with Sexing Technologies, that lab space is now being redeveloped to open a lab here again in the coming weeks. So it'll be operational by the start of November, and that lab will be producing semen straws for use during the 2022 breeding season.
And Stephen, we've spoken to you a couple of times previously because there's, I suppose, huge interest in the area of sex semen. One of the barriers that you would have mentioned in the past is the fact that those top EBI bulls are generally not available in the sexed semen straw form, given that they had to travel abroad, quarantine, and then the semen was collected and sorted. Going forward, given that there's a lab in Ireland, where do you see the genetics available for sex semen? Are we going to see those top bulls available in that form?
So to be fair to the AI companies, if you're relying on sending bulls abroad, there is always a biosecurity risk with bulls leaving your stud. So in general, those bulls would leave the stud, and in many cases, they'd never come back again. So for that reason, these were bulls that they had lots of conventional semen already made and stored in a tank. So these were bulls that were not a big risk to send away. So they were typically, as you say, mid-tier in terms of EBI. With a lab in the country, there is no biosecurity risk. You're not having to send bulls on a boat, and they're not going through any long quarantine process. So it should be possible to have much greater availability of the best team of bulls. And if we look internationally, that seems to be the way in most countries now. Most AI companies are providing the best bulls available in sex form.
I guess you have an ear to the ground in terms of speaking with farmers. How have you seen the use of sex semen evolved? Has it increased since you mentioned the I suppose the beginning in 2013? Yeah,
so after a slow start, it has definitely picked up pace in terms of interest. There was certainly a lot of interest from discussion groups and farmers in general in the 2021 breeding season. We've done a few more trials over the years, and each time we do one of those trials, we learn a little bit about how to use it appropriately and some best practice guidelines. And a lot of farmers have latched onto that now, and getting good results that they're satisfied with and seeing the benefits on the ground. So there has been a big increase in interest and uptake of sex semen, certainly in the last 2 or 3 years.
And I guess, as you say, the use of it, tweaking the practices have led to really good conception rates on farms. And a comment I would hear from farmers that use it is that, it's very comparable with the conventional AI straw in terms of conception rates. And I guess, it's what you come back to in your recommendations every year in terms of picking the elite cows, so your high EBI, cows that have calved, a significant amount of time, and so on. I suppose if we take a step back and look at the overall picture, there will be more sexed straws available now going forward, and elite straws. But if there is a big uptake of sex semen, nationally, will we compromise genetic gain of the national herd overall?
So that is a potential concern if we don't do anything about it to prevent that happening. So up until now, a lot of the bulls that are at least considered for AI or screened to be suitable for AI are born through mating events that happen without, they're mating events that farmers just happen to implement. So a farmer had a cow, mated her to a particular bull. When that calf is born, it gets flagged, I guess, as potentially being genetically of interest. And if it's genotyped and a very strong genomic proof is coming back from that testing, then that calf is potentially going to be a bull that enters AI. Now, like you said, if you take all the elite EBI cows and they're your preferred target for sex semen, then the number of elite male dairy calves is going to be particularly diminished. There's going to be much fewer of those. So we'll have to move from relying on matings that just happen to making those matings happen. And there's new ways of thinking about that. So one thing we could do very simply is just contract matings. So bull dams of interest, a farmer is contracted to mate that cow to a particular bull, and if it's a male calf, an AI company might be interested in purchasing that calf, or will guarantee that they'll purchase that calf. So that's one avenue. It's a bit limited in that you don't know if you're going to get a male calf or a female calf, but in any case, you're going to get one calf maximum per annum. Another avenue would be to get multiple mating events from particular bull-cow combinations each year. So this year in 2021, we did a fairly large trial to evaluate the use of it's not a new technology, it's been around for a long time, but I guess there's been a lot of improvements in it over the years. So the role of IVF, so in vitro fertilization and in vitro embryo production. So if you think about a normal breeding event, so a cow comes into heat, she's identified as being in heat, she gets inseminated at the appropriate time. Later that day, that cow is going to ovulate, release an egg. The egg gets fertilized in the reproductive tract, and the embryo starts developing and eventually makes its way to the uterus, and a pregnancy is established and maintained through term. What we're talking about here with this in vitro situation, so in vitro means in glass, so you're taking it out of the cow. So with this technology, you're harvesting eggs from the cow's ovary, you're taking it out of the cow, and you're fertilizing it in the lab. So you're all of the fertilization steps and the initial embryo development steps as far as day 7 take place in a lab environment. And there's quality controls that can be put in place. You can look at these embryos and make decisions as to their grade and if they're good enough. And if they're good enough, they can get transferred back into a recipient cow that has been synchronized to be on day 7 of her cycle. So a day 7 embryo, an embryo that's on day 7 of development, is transplanted back into a cow with a uterus that's also on day 7 of the cycle. So if you think about what you're able to do here, this one elite donor, this one elite cow or heifer that you're interested in, you could harvest eggs from that cow for a number of weeks, make multiple embryos, and put the embryos now into recipient cows that are not suitable themselves for generating replacements. So these are potential, the lower EBI cows in your herd that you're not interested in generating replacements from, but they are, potentially fertile cows that will be able to maintain a pregnancy from these embryos that you've developed. So, a cow could go from having potentially one pregnancy per year to having multiple, as many as 10 or 12 or 16 or however long you're going to collect eggs for. And by doing that, you're really maximizing the chance of having a high genetic merit offspring. Obviously, if it's a female, it's potentially of interest as a replacement heifer. But if it's a male, then it's potentially of interest as a future AI bull. So if there's a huge reduction in the number of male dairy calf births because of sex semen usage markedly increasing, something will need to happen to try and maintain the breeding program, to maintain the genetic gain in the breeding program. And what's happened in many countries is something like what I've just described, where there's a very targeted effort to maximize the number of pregnancies from the very elite top-end breeders.
You mentioned it's not a new technology, but it is an improving technology. And as things improve, as we have seen in the likes of sex semen, more people are going to use it. Right now, who would that technology be suitable for?
Yeah, so one of the things we were interested in the trial we did in Moorepark this year was how it would fit into a seasonal calving system. So the cows here, the donors, the cow donors all would have been calving during the month of February. The heifers obviously were not calving at all, but they were not long after puberty, and we wanted to assess how their performance how would they behave as donors, how successful would they be in terms of donating oocytes and producing embryos. So the cows would have been potentially as short as 4 weeks after calving when we started producing these embryos, and I can tell you that for the most part, the success rates were quite good. Almost all cows can be a donor. Having said that, there are definitely good donors and bad donors. So not all donors are going to give a lot of eggs, and even the ones that give a lot of eggs, not all of them yield a lot of embryos. But there's a lot of variation there. So who would this be of interest to? It's of interest to elite breeders that have very high EBI herds, potential bull dams that would be interested in maximising the number of pregnancies from the very best cows or heifers in their herd. And that's not just for dairy herds now. So we're concentrated here on the EBI, the very highest EBI herds. But we also have the DBI now, so the Dairy Beef Index, and this is a new index, very important for the dairy industry to recognise that there's a role to maximise the beef merit of the non-replacement offspring. But this is a new index, and to get genetic gain in that index is going to require a tool like this to focus on the very best dams and maximise the number of pregnancies from those very best DBI dams. And bear in mind, of course, that the DBI is a crossbreed, so there's multiple different breeds there to try and pick the very best and get some genetic gain for DBI, and ultimately with the consequence of increasing the beef merit of non-replacement calves on the dairy herd.
And looking at the open day booklet, we can see that ye have tested both fresh and frozen. Can you make a comment on that, and are there differences between the use of both products?
Yeah, so when you say fresh and frozen here, we're talking about the embryos. So the embryos are cultured in the lab until day 7 of development. And at that stage, they either need to be transferred back into a recipient cow that's synchronized to be on day 7 of the cycle, or they could be frozen for transfer at a later date. So, I mean, obviously it's attractive to be able to freeze it and store it, because you could be making these embryos at any time of the year, and you'd have a big bank of them available when the recipients are ready for the transfers. But the problem with the freezing is that it's a damaging step. There's a damage. There's some damage done to the embryo, and unfortunately the pregnancy rates with those frozen embryos are not as good as the pregnancy rates that we achieve with the fresh. In general, what we saw was that the embryos that were transferred in fresh had pregnancy rates that were comparable to AI, but the frozen embryos were poorer than that, and in general they were poorer than AI. So there's more work to be done there to try and develop new procedures, new methods to improve the pregnancy rates with those frozen embryos. But for now, I think farmers that are thinking about this, they'll be primarily interested in using fresh embryo transfer.
And Stephen, you mentioned that there can be a benefit of this technology to improving the quality and value of the non-replacement calves on farms. How would you propose this would work out?
Well, I mean, if we can get better bulls available, better DBI bulls available. There's a selection program required here now to advance genetic gain in DBI, but looking at the future here, farmers are going to be using a finite amount of sex semen to generate the number of replacement females they require. And if you look at the statistics on calf registrations in Ireland over the last number of years, typically the calf crop is about 30% female dairy calves, 30% male dairy calves, and the remainder is beef cross. So those beef cross calves are easily marketable. The female dairy calves are obviously they're going to be replacements. They're valuable, but it's the male dairy calves are the problem, and they're presenting an ongoing problem for the Irish dairy industry. We're reliant on the live shipping trade, and there's a lot of politics about maintaining that. But if sex semen was to be markedly increased, if you're using sex semen to generate your replacements, you can still get that 30% of the calf crop being female dairy calves. But if all your dairy inseminations are with sex semen, now your male dairy calf is down to only 3%, allowing the beef cross component of the herd, or beef cross component of the calf crop, to be 67%. And again, these are going to be much easier to market, much more saleable calves, and this will be important for the sustainability of the Irish dairy industry in the future.
And looking to the future, Stephen, as you say, this technology, not new, but it is improving. There's quite a few steps to the process. You mentioned this is something that may be of use to elite breeders right now. Obviously, this is early days in terms of research, but going forward, is this something, as a technology and a practice that might be used commercially across dairy herds in Ireland?
Well, okay, so on the very elite genetics part of it, it's obviously not going to be something that's applicable to all dairy farmers. But all dairy farmers are potentially interested in maximising the beef value of their offspring. So one thing that we are also looking at in the trial we did this year is collecting oocytes from beef cross heifers after slaughter. So these are heifers that are 2 years of age, and after slaughter their ovaries were collected. And the reason that this is of interest is that it's much getting oocytes or eggs from ovaries after an animal is being slaughtered is much cheaper, much quicker than it is to collect from a live donor. So which is what we're doing on the very elite end of things. So if you can get these ovaries for essentially very little cost, and you can harvest eggs much more quickly, then those what we'll call commercial beef embryos could be made available a lot cheaper than the elite breeding end of it. So the question that we're trying to get at here is, these commercial beef embryos, are they going to be a viable proposition for the dairy industry? And the things we're interested in here, obviously the pregnancy rates we're interested in, but after these pregnancies have been established, we're interested in calving difficulty for sure, gestation length, the viability of these calves when they're born, and then after that, all the way to the slaughter of these beef offspring. You know, they're all going to be somewhere between 75 and 100% beef breed genetics. So they should be quite different phenotypically from a 50% dairy genetics, 50% beef dairy cross calf. So, you know, at this point, we can't really say that it will be applicable to the majority of dairy farmers because we don't have that data. But if these animals have better carcass traits, better carcass value, or that they have lower costs of getting to slaughter, so that might mean better feed efficiency, or it might mean shorter days to finish, then maybe it is potentially something that's going to be beneficial to the dairy industry in the future. But it's something we've just started looking at now, and it'll take another period of time before we'll have some real data to support it one way or another.
It was really good to get some insight into the new technology that you're trialling here at Teagasc Moorepark. We look forward to following it over the next few years to see how it develops. Thank you, Stephen.
Thank you.
That's all for this week's episode of the Dairy Edge podcast, and my thanks to Stephen Butler for joining me on this week's show. Don't forget to rate, review and subscribe to the podcast. You can listen on Apple and Google Podcasts as well as Spotify. And for more information, go to the Teagasc website at teagasc.ie. I'm Emma-Louise Coffey, and join me next time for your Dairy Edge.